Welcome to the C++ introduction part of the course. I know that some of you are not familiar too much with C++ and would rather use Java or C#. However, I consider knowledge of C++ vital for high-performance computing, and hence I want to encourage you to use it in this course. So, I've seen a lot of C++ introductions and tutorials over the years, but the best still, in my opinion, is one I personally heard myself from an employee at Vienna University of Technology, Roland Lezuo, who kindly allowed me to reuse his slides for this presentation and this course. So these slides are intended to give you an idea and a starting point for someone who knows Java but has never programmed C++ before. But still, they might also be interesting for someone who has already some knowledge in C++. So here goes. I will show you how to get from Java to C++, what is different on a basic level. I will cover some advanced C++ topics that you might be able to use, and to give you a quick idea how to compile C++ projects. So these slides only show you how to do C++ projects under Linux, but I will add a separate small tutorial on how to do it in Visual Studio, which will be available in the lab at FH. So what is the perfect language anyways? What would we want from a language, programming language? It should be easy to learn and use. You should be able to do everything with it. You should be able to write your program once and run it everywhere, but it should be able to use platform-specific features, offer a high level of abstraction, and be efficient. The last thing particularly important for our course topic. And you could argue that all this applies to C++ and not Java. Of course, there is no such thing as a perfect language. Not even C++ is perfect. But still, we have some wishes for our language. First of all, orthogonality of features. That means that you can build everything you want in the language from a relatively small, simple set of components or tools with a relatively small set of possible combinations of those tools. You should be able to opt in and opt out of each feature. If you don't want to use it, don't use it. It should have static type safety, for example, so all your types of your program are checked at compile time. Syntax should be easy to understand, and even again interesting for our language, for our course, bindings for other languages. Can I call other languages from this language conveniently, like in this case OpenCL, in the case of our course? So what is C++ used for? These are just some examples. For instance, the kernel, the Mac OS X, or the Linux kernel is actually written in C. Middleware, like massive middleware, like Google uses it, or the ICE threading and distributed system middleware. For large applications like OpenOffice, LibreOffice. For games in particular, most games that run on consoles or on the PC are written in C++, and for embedded programs. So let's take a final look at a program in Java. Goodbye world. We have a class, and in this class we have a function public static void main with an arguments parameter, and we print out goodbye world. How does a comparable program look in C++, the Hello World program? So we start with two includes, which are the imports of libraries in C++, IOStream and cstandardlib. And we have a function int main with two arguments, rgz and rgv. And we write std cout, hello world, std endl, and then call exit. What differences can we see? First of all, there is no class. The Java program had a class before. Main is not static. and it has a return value. It's int, not void, as in Java. So the key differences are that C++ is an extension of C and mostly backwards compatible. So everything that is special about C is just optional and an extension. For instance, classes. You don't have to have classes if you don't want to. So main is usually always outside of a class definition. Everything outside that is outside of a class definition is also static in the sense of Java. You can call it without a class or an instance of a class, and the return value of main acts as a status for the operating system whether the program has failed or not, and is a must. You must supply that. Also, you can call int main with no parameters. That's also possible. Another big difference between C++ and Java is the separation of declaration and definition of variables and member functions. And in C++, declaration, saying that there is something, and definition, i.e. what it does, are separated. Declarations are in so-called header files only, and they contain the informations that are needed to use the class. And the definition, which means what the function actually does, is in a separate file including the header, and it implements the declarations made there. Let's look at a simple example. This is the definition of a class in C++. That's called myClass, has a private variable var underscore var, and some public variables and functions, members and functions. Let's look at it in detail. First of all, there are the so-called include guardians. These are the three lines that were preceded by a hashtag, if and def myClass HH, define myClass HH, and endif at the bottom. These you need to include in every class definition that you do if you include it into multiple files. Next, the class definitions, the class syntax in C++ has sections for private, public, and protected. So you don't precede every member of the class with private, public, or protected, but you do sections and then enter all your members and functions in there. There are also so-called inline functions. If you look at the function int get var, it has a definition straight away. The definition is just one line, return underscore var. So you can even define some functions in the header as well, and not just in the definition CPP file. There are default values for arguments that you can set. So looking at the function void set var, it has a parameter int var which equals 0. That means if you don't supply a parameter to set var, it will assume that the parameter, the argument, is 0. There is a constructor in the public section, myClass, and it has no return value. And in addition, what does not exist in Java, is a so-called destructor, which is the function tilde myClass, which is also defined here as an empty function. Let's recap that. Include guardians around the class definitions are simply needed when you include a class into more than one source file. This is just a constraint of C and C++ on how compiling and linking works. The inline function will be generated without creating a method, but that does not always work. So essentially you can inline functions that are very short, that only have like between 1 and 3 lines, and it might be a little bit faster because there is no function call involved. This is a more complicated topic, but I will not go into detail here. If you do not specify default constructors and destructors, they will be created for you, but they will just be empty functions essentially if you don't specify them. And so the headers define the interface to the class, but hide the implementation details. Aside from the inline functions, we do not know yet what all the declared functions do. That happens in the implementation file, which is usually a .cpp file. You include your header file, myclass.hh, and include some additional libraries, for instance, cstandardlib. and then you can define your functions, member functions. Whenever you define a member function of some class, you always have to precede it by class name colon colon. So in that case, you write my class colon colon my class to define the constructor of the class. And yeah, you initialize the variable with some random function. Similarly, you define the function void my class set variable by just setting the variable to some int value. You include the class header. You include the headers that are needed for the implementation, like cstandard_lib. Class is also the class preceding the functions is the so-called namespace for methods. You don't repeat the default value for arguments. As you might remember, in setVar we had a default value. You don't repeat it here. And there's also the possibility to overload functions, to have different functions having the same name, which is resolved at compile time. So you can have a function setVar that takes no arguments, or one argument or two arguments, and that will be resolved at compile time. But the return value must be the same, essentially, else you might get compile problems that will not work in C++. There are also, of course, C++ supports inheritance, so there are polymorphic functions. The class, some class child is a subclass of parents and parent that overloads a method. You can use a pointer to the parent call, but have a child instance. In that case, you need an ability to resolve the right function at runtime. You have to, the C++ has to decide, do you use the function, the polymorphic function of the child or of the parent? And in the background, this is done by the so-called vtable implementation in C++, which is a table in memory that decides for you which function to call of a parent or child class. There is additional cost at runtime for each call, but not too much. And essentially in C++ you can even control these costs. In Java you can't. How do you control them? By the keyword virtual. You can set functions to virtual or non-virtual, and that means that a method is called, if you have a function polymorphic member and you flag it as virtual, that means you can override it in a child class. However, if you do not include virtual, you cannot override it. It will always call the parent function. But it will be a bit faster. So you can actually decide which functions in your class hierarchy should be overridden and which ones should not be via the keyword virtual. Also, a method is called pure virtual if there is no implementation for this method. So you have, if you only want to implement this pure virtual method in child classes, which is essentially what you can do to mimic a Java interface in C++. There is no interface keyword, but you can have a class with only pure virtual functions that works the same as an interface in Java. And you have to mark them as pure virtual explicitly. So you write virtual int method equals 0. Then the C++ knows this is a pure virtual function and needs to be implemented in a child class. You see that you see already that C++ has quite complex inheritance support. It also supports multiple inheritance and non-public inheritance. The public inheritance is most important and does not change access specifiers of the base class. You will only use public inheritance for this course, I'm pretty sure, and I will not go into detail. You can do Java interfaces with pure virtual classes in C++. Methods that are to be overloaded must be virtual. If you don't declare it as virtual, they cannot be overloaded. And you have to supply a virtual destructor for base classes. That is really important. So if you ever have to want to create a child class out of your parent class, of your base class, you have the destructor of the base class has to be virtual. Else you might get memory leaks, but I will get into detail later. So let's look at an example again. We call a class myBase, and the function myBase has a virtual destructor which does nothing, and a virtual bool function that is called abstract. And we can also have a class called Java interface-like, which works like an interface in Java. Again, it has a virtual destructor that does nothing in the base class, and a function that int pure virtual, which equals 0, shows that it's a pure virtual function, and another one which is called myBool and is also pure virtual. Finally, you can create a class called myClass, which inherits from both myBase and Java interface-like, and then you have access to members of both. C++ objects differ from Java objects in the following aspects. C++ objects may be created on the stack. There is a difference in memory management between C++. In C++, they might be created on a stack, which does essentially garbage collection for you. You don't have to worry about the class being deleted. Or also you can create an object on the memory heap, which means you have to look into deleting it yourself, else you will get memory leaks. But more on that later. The operator equals normally copies an object. In Java you just have a reference. So if you use equals, you will get a copy of an object. And C++ objects created with the operator new must be deleted manually. There is no garbage collection. The destructor function that we mentioned before is called when the object is destroyed, which is guaranteed. Again, there is no garbage collection. So you have to care for garbage collection yourself under some circumstances. C++ also has the concept of pointers. Pointers are a way to access objects indirectly. So they are somewhat similar to references in Java, but again different. A pointer essentially points to an object. The content of a pointer is a memory address where the objects exist. So essentially you can think of the pointer to anything as just a number, just an int value, which is an address, to an object which might be arbitrarily large. And there is also the null pointer for pointing to no valid object. So for example, we can create two integers I and j, and we can create an int pointer denoted by int star pi, and then we can, for instance, assign the pointer to %i. That means pi is the address of I, meaning pi points to I42. You can set some objects via the pointer. So you write star pointer pi is 5. That means wherever pi points to, in that case I, will be set to 5. This is also called the dereference operator. Pi can be increased or can be used like an integer, which means that dereference of pi is 23 now. It points to the next object in memory. So you make the pointer point to a memory address which is the size of int further ahead after I, which means pi points to whatever lies in memory after I. That might be anything. In this case it will most likely be 23, but you cannot rely on that. So it's just an example to explain how pointers work, what they can do. And if you set pi to 0, pi is a null pointer and doesn't point to anything. With pointers comes the new operator. Say again, we create an int pointer pi, and pi is set to new int. That means there is a new object on the heap created, which will have to be deleted, garbage collected manually. But first you can set this pi, the object the pi points to 23. But if you set pi to new int, another integer is deleted and the reference to the first integer is lost, which means it's a memory leak. It's some memory that will never be freed again as long as your program runs, and you cannot get rid of it again. Also, pi is set to 42 now, and then you can call delete on pi, which frees the memory again of the second integer that you have created. Next to pointers, there's also the so-called reference. So let's again create some integer I and define it as 23. Then we can create a reference, int ampersand ri is I. That means that this ri points to I now. It works like a pointer with some differences. So every change of ri also changes I now. You can also not have uninitialized references. That means if you have a reference, it's like a pointer that can never be null or uninitialized. Also in functions, you can pass arguments as references. For instance, here in your int function, which has two string parameters, reference and copy, the first is defined as standard string reference, ampersand stands for reference, which means that the string will be passed as a reference to the function, and the second argument will be copied, which means any changes that you make to copy will not persist once the function is called. So let's create some standard string called str of the value 42 tiles, and calling the function with string and string means that the first string gets referenced in the function and the second one gets copied. If I call function with str and test, then test gets copied over, but if I call the function with the newly created test string and str, then you get an error because test is not a reference and not constant. So this is not something that persists during a function. Essentially, you have to use reference when you want to return values from a function, and constref is in particularly constref if you want to avoid copying data. Because copying the data of a string is quite expensive if the string is large, so you'd rather pass it by reference, which increases your performance. And yeah, if you use constref, you have the guarantee that the object will not be changed, which is again important in the aspect of functional programming, where a function does not change its input parameters. For instance, you can do this by writing int function const std string reference. Again, the stack versus heap topic. As I mentioned before, if you can either choose to create any object on the stack, which means it has limited lifetime and is deleted after when the function or part of the function goes out of scope, or you can create an object on the stack, which means it will live as long as your program runs, but you have to delete it manually. So in this function here, we can create an object pointer to some object and call but in the next line we create a new scope using the curly brackets. We create an object obj, which means the constructor is called on the stack. The object can be called to do something, and once we leave the scope of the curly brackets, the object will be deleted automatically. But we can also in here set the object, the OBGR pointer to some new object. By calling new, we allocate the object on the heap. In the next line, the destructor of obg is called. But once we leave that scope, we can still call the pointer OBGR to do something. But we need to delete it. Do not forget that later on. We can access stack objects using the dot as in Java, and using accessing heap objects or pointers, we use the arrow operator, which is a shortcut for parenthesis star object parenthesis close dot method. And the operator new on if you create an array on the stack on the heap, sorry, you need to call delete with angle brackets or square brackets, not delete without them. C++ also supports exceptions. Again, it's a bit more complicated than in Java because essentially you can throw anything you want when you have an exception. For instance, you define a class myException and then a class myClass, and this function has a destructor function which says throw afterwards, which means it can throw exceptions. And there is a function also void complex which throws int which calls a function throw with int and myException. The constructor, and this tells you it throws exceptions. The constructor itself may throw every exception. The destructor is essentially defined to not throw exceptions. The destructor must never throw exceptions. So in this example, that is actually a bad example. So this should not be done, and the complex function may throw int and myException, and any other type will cause the program to abort with an exception violation. You can catch exceptions. The syntax is quite as simple as in Java. You have a try block where you call something, and after the try block you call catch an integer, for instance an integer I or an exception E or something else. You don't have to catch as opposed to Java anything, and you should catch, and also you should catch references of the objects and not copies.